Assalamu alaikum. We are going to start our next lecture of compiler construction. So before we move to the next things which we are going to study, we will have a recap of our previous lectures. So far we have studied that what is a compiler. This would be a very brief, very short recap of the lectures. So we studied what is a compiler. We just had a simple representation that source program comes and compiler compiles it into target program. We also studied what is an interpreter, and then we had a little insight of what is an interpreter. After that we saw what is actually a language processing system, how a language is being processed, and we saw that compiler is a part of language processing system. Like compiler is not a complete language processor, but it is a part of language processing system, the language processing system which is being used in the computer. So more precisely saying, compiler is a phase in the processing of a language. So then we studied the compiler phases in detail. We had a lot of the phases of a compiler. So we will just see them in a little detail only. So we had the first phase, that is lexical analyzer. The character stream comes into lexical analyzer and it creates a token stream. Then token stream goes into syntax analyzer. Syntax analyzer makes a syntax tree and give that syntax tree to the semantic analyzer. Then semantic analyzer takes the syntax tree and it checks for the semantics, for the meaning, and then again produces a syntax tree with the little amendments if required. Then the intermediate code is generated. Intermediate code generator is a phase. After intermediate code generation, we have a code optimizer which optimizes the code and also gives us again intermediate code representation. After that, the code, another code generator which generates the target machine code, and then again optimization is done in the machine dependent code optimizer phase, and finally we get a targeted machine code. So in shortly, you can see in this picture, this is the short structure of a compiler. The three phases: first of all syntax checking, semantics checking, and then an intermediate code is generated, and then after that the other programming, you can say the target code is generated. So the part of the compiler that performs the analysis of the source language text is called the front end of the compiler, and the part that does the target language synthesis is called the back end of the compiler. So you can understand that whenever we are compiling the things, basically the synthesis or an analysis phase is actually where we are synthesizing the source language. We are checking the syntax, we are checking the rules and regulation of the language and meaning of the language, and we are generating an intermediate code. And then once the intermediate code is generated, the next synthesis phase, it is only concerned with the generation of the target language, the machine language, the language which computer will understand. So now we will talk about compiler. Now when we talk about compiler, we need to keep in mind that compilation is done when one program is written in some specific language. That specific program needs to be converted into some other language which is understood by computer. So it means basically compiler is dealing with languages, and that is why the language in which compiler itself is written. So that is why we understand here that compiler is related to the languages, and we studied that in our previous lecture. That is why we studied the languages. Some of the students might be thinking that why we studied that much theory about languages and all that stuff, but that is a very important thing. Whenever you Google some of the books for compiler, you will see that the first chapters of compiler constructions contain a lot of detail about the languages, a lot of detail which I am skipping right now, but later on if we needed these details, I will surely explain you these details, because without these details you won't be able to convert something. Just imagine if you are not having any idea about the language, how can you construct any compiler? How can you pick up, how will I say, tell you that this is some source program, this is a statement, and you are about to see this is identifier, this is a constant, these are terminals, non-terminals. For that you need to understand the languages, you must have some programming background, you must know what are the languages. That is why we studied the languages. So we study the source language, the target language. That is why we need to have the basic idea about the languages. So in our previous lecture we had some overview of languages, we studied the 5 generations of languages and I explained the details of all. Then we studied another classification such that imperative languages, declaratives, and other languages as well. So we just had an overview of these and you need to memorize these things as well. So now we will study further. So if the compiler has a very clean design, if we talk about a compiler and it has a very clean design, the front end is totally unaware of the target language and the back end is totally unaware of the source language. Source language is given to the front end and target language is synthesized by the back end. That is why front end is unaware of the target language and back end is unaware of the source language. इसका मतलब क्या है कि फ्रंट एंड को कुछ भी नहीं पता कि हमने कौन सी टारगेट लैंग्वेज बनानी है, वो सिर्फ सोर्स लैंग्वेज को पिक करेगा और उसकी चीज़ों को डील करेगा, उसको सिंथेसाइज करेगा, उसका सिंटैक्स देखेगा, उसकी मीनिंग देखेगा, उसकी सारी चीज़ें देखेगा. और जो बैक एंड है जिसने टारगेट लैंग्वेज बनानी है, क्योंकि उसको इंटरमीडिएट कोड मिलेगा तो उसे इस चीज़ से कोई लेना देना नहीं कि इंटरमीडिएट कोड कौन सी सोर्स लैंग्वेज से आया. So the only thing they have in common is knowledge of the semantic representations. There are technical reasons why such a strict separation is inefficient. And in practice, even the best structured compilers compromise. इसका मतलब ये है कि हम ये कहते हैं कि clean design वाले compiler में दोनों ends बिल्कुल separate होते हैं और उनके दरमियान बहुत अच्छा सा एक बाउंड्री लगी होती है, but in practical it is not possible. They have to compromise on certain things. So the front end of a compiler starts with a stream of characters which constitute the program text and is expected to create from it intermediate code that allows the context handling and translation into the target code. आपका फ्रंट एंड कहाँ से स्टार्ट होता है कि आप एक कैरेक्टर स्ट्रीम लेते हैं, वो फ्रंट एंड को देते हैं और वो उसका सिंटैक्स एनालिसिस स्टार्ट कर देता है और आखिरकार एक इंटरमीडिएट कोड जनरेट होता है जो लेटर ऑन एक टारगेट कोड में कन्वर्ट हो जाता है. It does this by first recovering the syntactic structure of the program by passing the program text according to the grammar of the language. It means you need to know the grammar of the language. Well, we have manuals in which the grammar of the language is written and all that stuff is already available. Since the meaning of program is defined in terms of its syntactic structure, processing these structures allows the front end to generate the corresponding intermediate code. क्योंकि आपके स्ट्रक्चर में ऑलरेडी आप बता देते हैं कि आपको आपके प्रोसेसिंग स्ट्रक्चर आपको अलाउ करता है कि आपको उसका मीनिंग समझ आ जाता है स्ट्रक्चर से. ऑल्दो सेमेंटिक्स इज ऑल्सो वेरी इंपॉर्टेंट, बट सिंटैक्स से भी मीनिंग हमें समझ आ जाता है, तो वो इंटरमीडिएट कोड जनरेशन में बड़ा इजी काम करता है. सो लेक्सिकल एनालिसिस इज द फर्स्ट फेज ऑफ अ कंपाइलर. दैट इज व्हाट वी आर गोइंग टू स्टडी इन डिटेल. Part of it will be discussed in this lecture and I will upload the other part of the lecture today and you will listen to that lecture as well, तो आपको उसका सारा idea हो जाएगा. So it takes the modified source code from language processors that are written in the form of sentences. Source code language processors जो हैं preprocessors, वो source code को प्रीप्रोसेसर क्या करते हैं, आपका सोर्स कोड लिखा हुआ है उससे रिलेटेड सारी की सारी चीज़ें इकट्ठी कर लेते हैं और उसके बाद आपने लैंग्वेज प्रोसेसिंग सिस्टम में भी पढ़ा कि प्रीप्रोसेसर का क्या काम है. इट जस्ट पिक्स अप ऑल द पार्ट्स और चंक्स ऑफ द कोड, ऑल द रिलेटेड फाइल्स रिलेटेड टू द कोड वट एवर कोड इज रिटन और प्रोग्राम इज रिटन, उस सब चीज़ों को लेके फॉर्म ऑफ सेंटेंसेस में लेक्सिकल एनालाइजर को प्रोवाइड करेंगे. द लेक्सिकल एनालाइजर ब्रेक्स दीज सिंटैक्सेस into the series of token by removing any white spaces or comments in the source code. अब वो उस सेंटेंस को पिक कर रहा है जो भी किसी प्रोग्रामिंग लैंग्वेज में लिखा हुआ है, उसमें से वाइट स्पेसेस को रिमूव कर रहे हैं, कमेंट्स को रिमूव कर रहे हैं और उसके प्रॉपर्ली टोकन्स बना रहे हैं. So if the lexical analyzer finds a token invalid, it generates an error. How will it find a token invalid? Let us suppose कि आपने कोई कीवर्ड एज अ वेरिएबल यूज किया हुआ है, किसी चीज़ का आइडेंटिफायर के तौर पे यूज़ किया हुआ है, और जब वो टोकन जनरेट करेगा, ये हम अब आगे भी डिटेल में पढ़ेंगे, ऑल्दो वो टोकन जनरेट करेगा तो इट विल अंडरस्टैंड कि भाई ये तो कीवर्ड है, we cannot use it as a variable name or identifier, so it will generate an error. The lexical analyzer works closely with the syntax analyzer. Obviously it has to create tokens and it will pass it to the syntax analyzer, and syntax analyzer will check it for syntactical errors and all that stuff. It reads character streams from the source code, checks for the legal token and passes the data to the syntax analyzer when it demands. Once the things are done on lexical analyzer, it has to pass data to the syntax analyzer. So you can see the picture in which you can see there is a source code, and source code makes lexemes. Lexemes are the words or the groups of words which are meaningful. The lexical analyzer creates token, it gives it to syntax analyzer, और वो request करता है tokens के लिए, वो request करता रहता है और ये provide करता रहता है क्योंकि कोड हमारा काफ़ी लंबा होता है. So what are tokens? Lexemes are said to be a sequence of characters, alphanumeric, in a token, and there are some predefined rules for every lexeme to be identified as a valid token. हम वैलिड टोकन्स बनाते हैं सीक्वेंस ऑफ कैरेक्टर्स को पिक करके. सो दीज रूल्स आर डिफाइंड बाय द ग्रामर रूल्स बाय मीन्स ऑफ अ पैटर्न. हमारे पास मुख्तलिफ रूल हैं टोकन जनरेट करने के, और उसके लिए हमें आपके अपनी लैंग्वेज के ग्रामर को भी अंडरस्टैंड करना होता है और इन माइंड रखना होता है. अ पैटर्न एक्सप्लेन what can be a token, and these patterns are defined by means of regular expressions. अब आपको पता होना चाहिए कि कंपाइलर कंस्ट्रक्शन पढ़ने के लिए आपको इससे पहले आपको थ्योरी ऑफ ऑटोमेटा का नॉलेज होना चाहिए. बिफोर यू स्टडी कंपाइलर कंस्ट्रक्शन, द प्रीरिक्विजिट फॉर कंपाइलर कंस्ट्रक्शन इज थ्योरी ऑफ ऑटोमेटा. The regular languages, regular expressions, context-free grammars, and all that stuff. I explained it in the previous lecture as well, that these things are very important and these will be used in your compiler construction. So in programming, language, keywords, constants, identifiers, strings, numbers, operators, and punctuation symbols can be considered as token. Like if some keyword is used and you are going to make a token, तो वो keyword का आप एक token बनाएंगे, variable use हुआ है उसका token बनाएंगे. So everything is considered as token, and we make tokens out of them. For example, in C language, the variable declaration line, let's say ये हमने variable declare किया, int value is equals to 100. This is a variable declaration. Value is the name, and its actual value is 100, and int is its type. So what we are going to do, first of all, when the lexical analyzer will start, it will see int is a keyword, then it will see value is identifier, equal sign is operator, 100 is a constant, and then this semicolon is a symbol. So first of all, lexical analyzer will see that what are these things are meant for and what are the meanings of these things. So specifications of tokens. Now what certain things can be token? Alphabets are token. What are alphabets? Any finite set of symbols like 0, 1 is a set of binary alphabets, or 1, 2, 3 and A, B, C is a set of hexadecimal alphabets. Like this is A to Z and capital A to Z, a set of English language alphabets. You have studied that in theory of automata. What is an alphabet? Alphabet is actually set of letters or set of symbols which are used to make the words of that specific language. What are strings? Now that's again a very basic question, that any finite sequence of alphabets is called string. and the length of the string is total number of occurrence of the alphabets. You pick up the alphabet and you make a sentence, you make a word. The sequence of alphabets is called a string. A string having no alphabets, a string of zero length, is known as an empty string, and it is denoted by ellipson or whatsoever we used to denote it with something else in the theory of automata. Then again we have, what else we have in programming language that can be used as token is special symbols. So these are some typical high-level language. Typical high-level language contains the following symbols, and you can see that arithmetic symbols, punctuation, assignment, the special assignment, then comparison, preprocessors, location specifiers, logical operators or shift operators, and etc. These are some typical special symbols, although we have a lot of other special symbols as well. Then what is a language? Obviously, if we have alphabets, strings, we have special symbols, then obviously we're talking about a language. So I would say that we have studied the definition of languages. So a language is considered as a finite set of strings over some finite set of alphabets. So computer languages are considered as finite sets, and mathematically set operations can be performed on them. So finite languages can be described by the means of regular expressions. We have regular expressions by which we can identify certain languages, or any language which is finite. Regular expression can represent that language, and obviously on regular expressions we can perform set operations. So when we do the lexical analyzer, we have to keep in mind all these things, all the regular expressions, the regular languages, and then later on you will understand the many rules of theory of automata. Context-free grammars will be studied in detail. And then we have a longest match rule. What is the longest match rule? Longest match rule means that when the lexical analyzer reads the source code, it scans the code letter by letter. And when it encounters a white space, operator symbol or special symbol, it decides that a word is completed. अब एक वर्ड उसने पढ़ना स्टार्ट किया, और जैसे ही वाइट स्पेस या कोई ऑपरेटर सिंबल या कोई स्पेशल सिंबल आया तो उसे पता चल गया कि ये पिछला वर्ड यहाँ पे कंप्लीट हो गया. While scanning both lexemes till int, the lexical analyzer cannot determine whether it is a keyword int or initials of an identifier int value. अब यहाँ पे एक एग्जांपल है, जैसे हमने int value is equals to 100 देखा, तो उसमें हमने ये देखा कि जब उसे स्कैन करना स्टार्ट करेगा, int के बाद वाइट स्पेस है. when white space encounters, तो उसे पता चला कि ये int खत्म हो गया. जब तक वाइट स्पेस नहीं आती, it just keeps on thinking कि ये int जो है वो कीवर्ड है या int से कोई और वर्ड स्टार्ट हो रहा है जिसके फर्स्ट वाले लेटर्स I N O T हैं और ये एक आइडेंटिफायर है. लेकिन जब उसके वाइट स्पेस आ जाती है तो longest match rule states that lexeme scan should be determined based on the longest match rule among all the token values. वो मैच करता रहता है सारे के सारे कीवर्ड से. Lexeme analyzer also follows the rule priority where the reserved word, a keyword of a language, is given priority over user input. वो उसको longest rule के मुताबिक उसको मैच करता है हर एक कीवर्ड से, और अगर वो किसी कीवर्ड से मैच हो जाए तो पहली प्रायोरिटी कीवर्ड को दी जाएगी, और अगर यूजर ने उसको यूज किया है कीवर्ड को एज आइडेंटिफायर और लेक्सिकल एनालाइजर को पता चल गया कि दैट वाज अ कीवर्ड बट इट इज यूज्ड एज आइडेंटिफायर, इट विल prompt an error message. एंड इफ इट इज यूज्ड एज अ कीवर्ड एंड इट इज आल्सो अ कीवर्ड, तो वो उस चीज को क्लियर कर देगा और उसे चला देगा आगे. दैट इज इफ लेक्सिकल एनालाइजर फाइंड्स अ लेक्सीम दैट मैचेस विद एनी एग्जिस्टिंग रिजर्व वर्ड्स, इट जनरेट्स एन एरर. So this is our first lecture is completed here. First lecture is not completed. I mean to say the first part of this lecture is completed here. You will have the other part as well, but I think the short video will be fine because you find it so hard to hear all the long video. So I will shortly upload the next part of this video. So if you have any questions, you better know all the method of the question, so you can do this. Thank you very much.